Hi everyone, this is Colin from Better Explained. Thanks for signing up for the calculus course. I'd like to give you a quick overview of the course and then we can just hop into it. These videos will just be a few minutes, enough to give you a good overview and intuition so then you can read the article text, which won't be too long, but so you can read it and actually get kind of a deeper understanding. So these videos, quick primers, and then you can read the text, or if you want, read the text first and then watch the video as a summary. Okay, let's hop in. The first insight, which I've written about previously for the course announcement, but it's basically the idea of going from blurry to sharp when we're learning. So oftentimes when we teach a course, we kind of cover things in full depth and sort of try to go linearly. So if we're doing a video, if we're doing an image, we kind of get full detail and we do the top and then the middle and the bottom. And the problem with that is, one, it's kind of boring because in the beginning you only kind of see, the forehead, you don't know what's happening. But two, also, it doesn't really cater to how humans actually work, or at least how I actually work. I like to see the big picture and then sharpen the details. It's more interesting to me, and also I can kind of see how things connect. I mean, when you see the top of a forehead, you're not really sure what's happening. Is he on a surfboard? Is this a man or a woman? You don't really know. When you see the overall portrait, the details kind of fit into place a lot better as they sharpen. So that's kind of my first insight about why we teach things a certain way. The next is actually understanding the difference between kind of appreciation and performance. So, for example, with music, we understand there's different levels of knowing music, right? I can just know rock and roll. I can recognize it, or I can describe it, or maybe I can even write down the sheet music for it, or I can play it, or I can even talk about the theory about why rock and roll sounds like rock and roll, or why sad music sounds sad, or how harmonies work. And there's different levels of understanding, and we don't have to go to the deepest level. Everyone has their own goals, which is completely fine, including just the top levels of appreciation and natural descriptions, which I notice a lot of people are interested in. But also, if you want to go down to the deeper levels, we have that too. But please don't feel like you need to go to the deepest level just to get some kind of takeaway from math, because especially like with music, we don't think that unless you can play it, you shouldn't listen to it. Lastly, the last difference that this course takes from a lot of calculus courses is that most of them teach you the most modern version of calculus, which was kind of developed by Newton, and in the 1700s it kind of got sharpened up. But calculus is actually quite old. Archimedes, working in the hot sun, was figuring out results on his own. He didn't even have decimal points. He was working with fractions. He's really old school, by the way. So he was working out these theories and these concepts, and that kind of laid the groundwork for what a lot of people did later. And so we kind of skip all that and we jump to the most modern version. But that's like, putting someone in an F1 racer instead of letting them drive kind of a slower car and seeing how things work. So we're going to take our time. We're going to go through geometry, which is kind of very visual, very easy to see the results of. And it's actually pretty applicable. You can look around and you see shapes everywhere. And calculus will actually help you think about everyday objects a little bit differently. So with that background, let's hop into it. If I can describe calculus in 1 minute, don't time me, but it'll be maybe really short. It basically gives you two superpowers. Here they are. The first is that you have X-ray vision. What does that mean? Well, you can look at something like a tree trunk and you can see that inside of it are a bunch of rings. So you kind of, you scan it and you can see the interior structure. That's a pretty cool power. The second is you actually get time-lapse vision. And so for this, let's say you look at the moon and you say, well, here's where it is today. Bup, 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 bup. In 6 days, it'll be at this point in the horizon in this color. So I'll come back and take my photo then. So you sort of have these two kind of similar and complementary skills. One is to take things apart and sort of see what's inside them, and the other is to kind of extrapolate forward and see where it's going. And calculus is sort of the art of using these powers. And that seems really kind of vague, though. I mean, they're cool powers, but how do we actually use them? Let's give it a shot. So, like we said, we're talking about geometry. Here's a couple kind of geometric facts that, you might have seen before. And honestly, you probably had to memorize, right? I have to memorize them usually. It's just, okay, there's a bunch of pi's and r's and 4's and 3's and squares. I mean, it's a lot of stuff, but it seems like they should be related, right? And they are related, but we don't really have the insight to see it without calculus. Calculus gives us the kind of viewpoint which makes these seemingly different facts click. So let's try it out. One insight from calculus is actually that we can dissect a circle into rings. This is just like the tree trunk, right? We saw that a tree is made out of a bunch of rings. Well, why not a circle? We could think of a circle as just being made out of a bunch of rings. Okay, I mean, yeah, it's a nice little what-if scenario, but how does that help us? Well, here's the trick. rings are a lot easier to work with than circles. Rings are almost rectangular, right? You take them apart and you unroll them and they kind of make a little rectangle. Circles are really curvy and hard to work with. I mean, you can't really put a ruler on a circle. But if you take a bunch of little rings, I imagine little pipe cleaners almost, right? You have those little pipe cleaners that you can bend. I imagine taking those, making kind of a circle, and then unrolling them and lining them up. And what happens when you do that? Well, you have how many? We're actually taking rings from the center all the way out. So we have kind of R of them, or R amount of width there. And the biggest ring is kind of all the way on the outside. So that's 2 pi r. That's really the only fact we need, is just how big the biggest one is. And then we know the area. This kind of makes a triangle. And then if we kind of had more rings, it would be a smoother triangle. Imagine a triangle so fine that each ring was just kind of 1 pixel wide. Once we take that, we can do area is 1/2 base times height. And so we measure this triangle, and it turns out that it's pi r squared. So whoa, this is pretty cool, right? We took this kind of, I mean, I don't want to say immeasurable shape, but this really difficult to measure shape, and split it using our X-ray vision into a much easier to measure shape, and just measured that. And so that's just like a taste of the power of calculus, where we can look at a shape and analyze it a little bit differently. And with that superpower, we know a new fact. I mean, we looked at it and we turned this kind of blob into something measurable. So that's sort of the key. I call it like the kind of 10-minute overview of calculus. What kind of viewpoints does it give you? Now, a lot of people ask, well, what can I do with calculus? And that kind of question, some people try to bend over backwards and say you can do so much. No, it's really up to you. What can you do with numbers? I mean, our ancestors thousands and millions of years ago, they didn't really need numbers. They didn't live too long, but they didn't really need numbers, right? Numbers are sort of a way of thinking, of quantifying things. You don't have 2 piles of rocks. You don't have a big and a small pile. You have a pile of 10 and a pile of 50. And you can, work out some facts with that. And once you have this idea of numbers, it's really hard to give up, because we kind of quantify everything. How are you feeling? 1 to 10. Your job satisfaction, 1 to 10. Surveys. We sort of implicitly want to quantify things because it's so useful. Calculus is similar. Once we really understand it, we want to take things with a step-by-step viewpoint. You don't have to, but oftentimes it does make things easier to sort of break them down into little pieces and say, hey, is there a pattern here that I missed the first time when I looked at the blob? And again, these are sort of really high-level insights, and without a lot of examples, it's kind of hard to think about. So this course will have a lot of examples where we're trying to look at shapes and understand what's happening from a calculus point of view, and not get into the equations at first, but just feel what is it like to think with calculus. So that's my high-level intuitions. Hope you enjoyed this. Happy math.